अस्सलाम वालेकुम एवरीवन। सैटरडे
Right.
वेबिनार शुरू करते हैं आई कोड गुरु के इंट्रोडक्शन के साथ। लेट मी शेयर माय स्क्रीन।
Muskan, are you talking to me?
नो सर।
Hmm.
सर मैं स्क्रीन शेयर कर लेती हूँ अपनी आई कोड गुरु के इंट्रोडक्शन के लिए। देन सर आफ्टर 5 मिनट्स सर यू कैन स्टार्ट। लेट मी शेयर माय स्क्रीन फॉर द इंट्रोडक्शन।
Sure, thank you.
यू वेलकम सर। वेट होप सो माय स्क्रीन इज विजिबल। मैम लिंता, क्या मेरी स्क्रीन विजिबल है?
Yes, ma'am.
शुक्रिया। अस्सलाम वालेकुम एवरीवन, वंस अगेन दिस इज मुस्कान, वन ऑफ द मॉडरेटर ऑफ आई कोड गुरु। सैटरडे वेबिनार शुरू करने से पहले आई कोड गुरु का इंट्रोडक्शन। आई कोड गुरु का इनिशिएटिव सिलिकॉन वैली के टॉप इंजीनियर्स ने लिया है और आई कोड गुरु का मोटो है शेयर लर्न एंड ग्रो। आई कोड गुरु पे हम अपनी नॉलेज दूसरों के साथ शेयर करते हैं, दूसरों के नॉलेज से लर्न करते हैं और एज अ कम्युनिटी हम एक साथ ग्रो करते हैं। आई कोड गुरु का मिशन क्या है? आई कोड गुरु का मिशन है एम्प्लॉयबिलिटी को इंक्रीज करना, हाई टेक स्किल्स जो मार्केट में इन डिमांड है स्टूडेंट के साथ उनको इंट्रोड्यूस करवाना और इंटरनेशनल मेंटर्स के साथ मीटअप कराना हैकाथॉन्स और वेबिनार्स की शक्ल में। आई कोड गुरु का फोकस क्या है और हाउ डू वी वर्क? आई कोड गुरु पे पर डे 20+ सेशंस रन करवाए जाते हैं और एक वीकली वेबिनार, सैटरडे वेबिनार जिसमें हम सारे भी मौजूद हैं। 2 वीकली वर्कशॉप्स कंडक्ट करवाए जाते हैं स्टूडेंट्स की लर्निंग के लिए। देन आई कोड ग्रुप पे पाइथन फॉर एब्सोल्यूट बिगनर्स के मल्टीपल सेशंस रन करवाए जाते हैं ताकि स्टूडेंट्स अपनी अवेलेबिलिटी के मुताबिक हमें ज्वाइन कर सकें। और आई कोड ग्रुप प्रमोट करता है 100% फ्री आर्ट्स डीटी यानी कि डुलिंगो जीआरई कोर्सेज और टोफल के कोर्सेज ताकि हम इजीली फ्री प्रिपरेशन के साथ स्कॉलरशिप के लिए तैयार हो सकें। इसके अलावा आई कोड गुरु डीएसए लीड कोड और इंटरव्यू प्रेप क्वेश्चंस की भी तैयारी करवाता है जो कि लीड कोड है, ताकि हम फैंग जैसी बिग कंपनीज को टारगेट करें और इजीली उनके जो इंटरव्यूज हैं वो क्रैक कर सकें। मशीन लर्निंग, डेटा साइंस, डेटा एनालिटिक्स, जेएनएआई जैसे एडवांस कोर्सेज भी आईकोड गुरु पे रन करवाए जाते हैं और इन तमाम सेशंस की रिकॉर्डिंग आईकोड गुरु के यूट्यूब चैनल पे मौजूद है। अगर कोई लाइव सेशन आपका मिस हो जाता है तो आप वहाँ से वॉच कर सकते हैं और मजीद अपडेट के लिए यू कैन गो थ्रू आईकोड गुरु का एफबी पेज। तो बात करते हैं आईकोड गुरु के रिसेंट अचीवमेंट्स के बारे में। तो ये कुछ चंद एक अचीवमेंट्स हैं आईकोड गुरु की जो यहाँ पे डिस्प्ले हैं। हम देख लेते हैं उन्हें कि 700+ इंटरनेशनल अवार्ड्स हैं हैकाथॉन्स में और कोडिंग कॉम्पिटिशन्स में। इसके अलावा आईकोड गुरु हेल्प आउट करता है अपने स्टूडेंट्स की फुल्ली फंडेड ग्रेजुएट एडमिशन्स की ऑल ओवर द वर्ल्ड, स्पेशली यूएसए। आईकोड गुरु हेल्प आउट करता है लोकल और इंटरनेशनल इंटर्नशिप्स और जॉब्स के लिए जिन डॉक्यूमेंट्स पे हम काम कर रहे होते हैं स्टूडेंट्स के, जिन डॉक्यूमेंट्स पे हम काम कर रहे होते हैं स्टूडेंट्स के, डेफिनेटली उनके चांसेस जो हैं वो अपग्रेड हो जाते हैं। हम सीवी पे काम कर रहे होते हैं, मोटिवेशन लेटर्स पे काम कर रहे होते हैं, एलओआर पे काम कर रहे होते हैं, तो आईकोड गुरु के स्टूडेंट्स के चांसेस इंक्रीज होते हैं जिसकी वजह से वो इजीली ग्रैब कर लेते हैं इंटर्नशिप्स, जॉब्स और स्कॉलरशिप्स। मुझे नहीं लगता है कि ऑडियंस में से कोई स्टूडेंट मौजूद होगा ऐसा जिसको पता नहीं होगा टॉप टीयर यूनिवर्सिटीज़ का, जिसमें हार्वर्ड यूनिवर्सिटी, स्टैनफोर्ड यूनिवर्सिटी, एमआईटी, यूसी बर्कली की यूनिवर्सिटीज़ के नेम आते हैं। तो आईकोड गुरु के स्टूडेंट्स के इनमें भी इंटरनेशनल अवार्ड्स हैं। फॉर एग्जांपल CS50X पजल डे जो कि आफ्टर 1 वीक दोबारा से अनाउंस किया जाएगा ट्रेनिंग सेशंस के लिए। तो लास्ट ईयर 2025 में आईकोड गुरु से 259 टीम्स ने पार्टिसिपेट किया, ना कि सिर्फ पार्टिसिपेट किया बल्कि 9 बाय 9 पजल्स को सॉल्व किया और हार्वर्ड के में इस इवेंट में अपनी जगह बनाई। टॉप 1 में बिफोर अमेरिका। देन स्टैनफोर्ड यूनिवर्सिटी 2025 इवेंट कोड इन प्लेस, जो कि बड़ा एक प्रेस्टिजियस इवेंट है, और इसमें हमें मौका मिलता है कि हम 1-to-1 इंटरनेशनल स्टूडेंट्स को पढ़ा सकें पाइथन और कैरल प्रोग्रामिंग, जिसमें आईकोड गुरु के 240 मेंटोर्स को ये मौका मिला कि उन्होंने इंटरनेशनल स्टूडेंट्स को पढ़ाया स्टैनफोर्ड के इस प्रोग्राम में। देन 3 आईकोड के स्टूडेंट्स MIT इमर्जिंग टैलेंट प्रोग्राम में फुली फंडेड ट्रैक पे इन्होंने सिक्योर किया, जिसमें 8,000 पार्टिसिपेंट ने अप्लाई किया, 320 ग्लोबली सिलेक्शन हुई, और अगेन उसमें भी 3 आईकोड ग्रुप के स्टूडेंट शामिल थे। 301 स्टूडेंट जिन्होंने आईकोड ग्रुप की तरफ से पार्टिसिपेट किया था गूगल कोड जैम में 2023 में, विच इज़ वन ऑफ द हाईलाइटेड न्यूज ऑफ 2023। 3 इंटर्न्स इतिहाद एविएशन ग्रुप में अ, उन्होंने ज्वाइन किया अबू धाबी में एक इंटरनेशनल हैकाथॉन विन करने के नतीजे में। तो ये एक पोस्टर है, इस स्लाइड पे हम देख रहे हैं कि फॉल 2024 फुली फंडेड स्कॉलरशिप्स इन यूएसए, जिन पाकिस्तान की यूनिवर्सिटीज़ के स्टूडेंट ने यूएस की 19 यूनिवर्सिटीज़ में फुली फंडेड MS और PhD के स्कॉलरशिप लिए, वो आईकुड गुरु के प्लेटफॉर्म से ताल्लुक़ रखते थे, जिसमें यूनिवर्सिटी ऑफ एग्रीकल्चर फैसलाबाद, कायद आज़म यूनिवर्सिटी, इंटरनेशनल इस्लामिक यूनिवर्सिटी, मोहम्मद नवाज शरीफ यूनिवर्सिटी ऑफ मुल्तान, UET लाहौर, यूनिवर्सिटी ऑफ गुजरात, बहरे यूनिवर्सिटी और GCUF के स्टूडेंट शामिल हैं, जिन्होंने 2024 में US की 19 यूनिवर्सिटीज़ में फुली फंडेड अपॉर्चुनिटीज़ को ग्रैब किया, जिसमें मास्टर्स और PhD के फुली फंडेड एडमिशन शामिल हैं। तो बात करते हैं 2025 फुली फंडेड स्कॉलरशिप्स इन USA। पाकिस्तान की टॉप टियर यूनिवर्सिटीज़, टियर 2 टियर 3 यूनिवर्सिटीज़ के स्टूडेंट जिन्होंने US की 38 यूनिवर्सिटीज़ में 2025 में एडमिशन सिक्योर किए फुली फंडेड, उनकी कुछ जो स्कॉलरशिप होल्डर की प्रोफाइल्स कुछ इस तरह से थी, वो हम देख लेते हैं कि CGPA की रेंज 3.1 टू 3.8, आइट्स रेंज 6.5 टू 7.5, किसी की कोई पब्लिकेशन नहीं थी, किसी स्टूडेंट ने कोई GRE नहीं दिया, स्टडी गैप भी ज़्यादा था 1 to 15 ईयर्स का, और सब ने 100% फी वेवर के साथ अप्लाई किया आईकोड ग्रुप के स्टूडेंट्स ने। और स्कॉलरशिप्स के जो स्टाइपेंड थे वो है $1,100 टू $3,000 पर मंथ। आईकोड ग्रुप के स्टूडेंट्स ने अब तक कोई बैंक स्टेटमेंट शो नहीं करवाई। तो ये एक बार ग्राफ है, इस स्लाइड पे हम देख रहे हैं कि आईकोड गुरु की कम्युनिटी किस तरह ईयर बाय ईयर इंक्रीज हो रही है। सो 2021 में जब आईकोड गुरु का इनिशिएटिव लिया गया तो आईकोड गुरु के कम्युनिटी में 5,000 मेंबर्स मौजूद थे, और अगर बात की जाए 2026 की तो आईकोड गुरु की कम्युनिटी पर इस टाइम 125 के मेंबर्स जो हैं वो मौजूद हैं विद दीज इंटरनेशनल अचीवमेंट्स। थैंक यू सो मच फॉर ज्वाइनिंग दिस सेशन। आईकोड ग्रुप रजिस्ट्रेशन के लिए यू कैन गो थ्रू icode.guru/join। आईकोड ग्रुप के FB और YouTube चैनल को भी आप विजिट कर सकते हैं। तो बात करते हैं आईकोड ग्रुप के सैटरडे वेबिनार टाइटल के बारे में, जो कि है हाई परफॉर्मेंस मटेरियल्स फॉर पावर जनरेशन, और हमारे गेस्ट स्पीकर हैं सर आदिल। सबसे पहले वेबिनार में सर आदिल का वेलकम करते हैं विद दिस शॉर्ट इंट्रोडक्शन, कि सर आदिल ने अपनी PhD जो है वो एक टियर 1 यूनिवर्सिटी से की है, यूनिवर्सिटी ऑफ पिट्सबर्ग से, मेटलर्जिकल इंजीनियरिंग में। और अगर सर के एक्सपीरियंस की बात की जाए तो सर का जो एक्सपीरियंस है वो 40+ ईयर्स का एक्सपीरियंस है, यानी कि हमें सर से सीखने को बहुत कुछ मिलेगा इस वेबिनार में। और सर ने अपने करियर की जो अपने एक्सपीरियंस की या करियर की जो शुरुआत है वो इस तरह से की है कि डेवलपमेंट लीडर एंड क्वालिटी मैनेजर टू इंजीनियरिंग मैनेजर एट पेरेक्सियर कंपनी से। और सर ने देन उसके बाद ब्लूम एनर्जी कंपनी ज्वाइन की एज अ सीनियर प्रिंसिपल इंजीनियर, और करंटली ही इज वर्किंग एज अ डिस्टिंग्विश्ड इंजीनियर एट ब्लूम एनर्जी। सो प्लीज जॉइन मी टू वेलकमिंग सर आदिल। और सर थैंक यू सो मच फॉर योर टाइम फॉर दिस वेबिनार टॉक। तो मैं अपनी स्क्रीन शेयरिंग ऑफ कर लेती हूँ, और जी सर ओवर टू यू एंड
Okay.
थैंक यू सर।
Thank you, Muskan. Let me share my presentation. So, first of all, it's a very impressive organization, iCode Group. I had an opportunity to attend the fundraiser last weekend, and I know the founder, Dr. Shai Zafar. And first time I learned just a few months ago what iCode Group is doing. It's amazing work, and so I like to make a small contribution towards this mission कि बच्चों की हेल्प करते हैं पाकिस्तान के, और उनको ट्रेन करते हैं, उनको प्रिपेयर करते हैं यूनिवर्सिटी एडमिशन स्कॉलरशिप्स के लिए, विच इज़ अमेजिंग। अच्छा, तो मैं आपको शेयर करूंगा अपना एक्सपीरियंस। पहले तो मैं बताऊंगा अबाउट माई सेल्फ और करियर पाथ, my extracurricular activities. Hopefully, you can learn something positive. And also, then I'm going to share technical experience of what I have. हालांकि एम्फेसिस मुझे लगता है कि सॉफ्टवेयर आजकल सॉफ्टवेयर इंजीनियरिंग की है और computers and all this, but I have a very narrow experience in metallurgical engineering, especially narrow in high temperature materials. That's my specialty. So in at Bloom Energy, currently I'm working as a distinguished engineer, or you can call it subject matter expert. And the expert means who knows maximum about minimum. So that's how I define that. I know maximum about minimum. तो खैर आप देखेंगे और चलें स्टार्ट करते हैं। कोई क्वेश्चन इससे पहले? Okay. Can you see my presentation?
Yes, sir, visible.
देख सकते हैं, अच्छा। Okay. So, as I said, agenda is a personal journey, major industrial experiences, aerospace engines, and land-based gas turbine engines were used for power generation. And more recently, solid oxide fuel cell, again for power generation. And both of these operate at very high, at least some part of these systems operate at very high temperature. So gas turbine engine and an aerospace engine, the hot section of the turbine blades are 1100 degrees Celsius or higher. And for solid oxide fuel cell power generation, the main core of the system runs 800, 900 degree Celsius. So you need materials which have high strength at temperature, because everything kind of weakens at high temperature, and also surface stability. Wo at this temperature they won't corrode, oxide will form and they lose their material. So those are the two emphasis: high temperature strength and surface stability of the material when you select the materials for the turbine blades or for the fuel cell. I'm recently dabbling into advanced computational techniques in material science. So developing material is something called density functional theory, which uses quantum mechanics. I don't know if we'll have time to go through, but this is the new area, and high entropy alloys and machine learning. So all this AI is also used in materials. So you always need new materials which can withstand high temperature, or also lower temperature. They retain their properties, or they have special properties such as conductivity, electrical conductivities, or the thermal conductivity. So you always need new materials. So it's a very fertile area for research, and especially after this AI uh, and advanced quantum computing, you will see that how this new materials will be developed quickly. Okay, this is future. मैं आपको, so I have to remove that. Okay, so personal journey. So I did my matriculation from government public school, Urdu medium, Karachi. There was a school in Jangir Road, government secondary school, and so that was a good experience. Then I did intermediate from SM Science College, which is located right in the center, city center. Sindh Madarsa, agar aap logon ne suna hai, that college was there, SM Science College, and I think that gave me the really foundation of science fundamental, which I use still. So this was professors were very good at that college, and those fundamentals which I learned in my intermediate, I'm still using those and those. So please pay attention to those first formative years of science. That's where, if your fundamentals are good, it's easier to move forward. उसके बाद मैंने बैचलर ऑफ इंजीनियरिंग किया फ्रॉम इन मटेरियल्स इन metallurgy from Dowd University of Engineering Technology. Recently, I visited 2 weeks ago, and I also gave a seminar there. And that university is doing well. So that was my learning about the engineering and metallurgy. After that, I worked for 1 year at Neador Motors, Karachi. And I did the summer intern also. You volunteer. In America, you summer intern, you get paid. But in Pakistan, we just went to there, and they were very nice to have us for summer program. And वहाँ काफी learning हुई, but they didn't pay, of course. This was all volunteer work. Although I had a first class first position in the Bachelor of Engineering at Dowd University, I could not get any scholarship. So this is the difference, that you need some help to really the iCode gurus, what they're doing, preparing a student, getting help them get the scholarship. So despite having first class first position in my class, I could not get any information, any scholarship. So I remember one thing that. Governor of California, Schwarzenegger, he said nobody is self-made. So it's a misnomer, self-made. Everybody needs help. So in my case, help came from the family. My brother helped me to get me into the University of Sheffield, or actually supported, financially supported me to get to the University of Sheffield in UK, which is a very good university for materials or metallurgical engineering. And that was a amazing training. We used to have classes, and then we will go to industry to talk about their problems, solve their problems, and discuss the solutions. So I did that in 1 year. After that, yes, of course, I have something under my belt. I could get the scholarship from for PhD in material science from University of Pittsburgh. So then I went to the University of Pittsburgh, did my material science PhD, and my PhD topic was again high temperature materials, and I was studying research. My research was around studying the failure of the oxide which forms at high temperature as a reaction with the air, 1100 degrees C. So it can form oxide and corrode very fast. So I was studying that using a new technique of acoustic emission. So when oxide scale crack, it sends some elastic wave, acoustic wave, which you cannot hear because it's an ultrasound level, but you can tell when it's cracking. And the oxide is very thin, micron thin. So there's no way you can detect by any other means. So that was my PhD. Then I worked. I said Lindy, but in my resume you will see Praxair, because now the new name of the company is Lindy Group. So that's where I worked 20 years or more for aerospace alloys and coating. I was working with the FAA, Federal Aviation Administration repair station, where we will repair the engine, especially hot section of the turbine blades. Currently, for 14 years, I am at Bloom Energy, and they have the unique thing of fuel cell power. Bloom Energy is started from scratch, developed this new technology, and right now it's very hot in terms of AI data center. So this power generation system, our power generation system from Bloom, are very well suited for power generation for the data centers. Uh, and I published dozens of papers in peer review journals, and then I have over a dozen, probably 16 US patents and international patents on this in this area. Just to tell a little bit more about all work, no play makes a boy dull. So I am also, since when I was studying for PhD, I had to have some kind of out. So I started running, and I found out that I could run pretty good in that late time. When I was in Pakistan, I didn't do much athletics, but then I started running, and I ran about 20 full and half marathons. I also do road biking now. My knees are not that good, so I'm doing road biking and skiing. I also support many schools in Pakistan. So this is the two photos shows some elementary school which my brother runs, and then there are 12 coaching centers who prepare for the kids from ninth grade to 12th grade to go to professional colleges. So I'm very involved in supporting education in Pakistan. Okay, so much about myself. Um, Oh, I just wanted to show some photos when I was a young intermediate student. So I did look like some of you guys probably now. And then I'm showing this middle photo that doing a PhD research. And then the current is my current photo, just to make it a little bit more colorful. Okay, so now is there any question right now? Um, Also, I tend to slip into English because there's so much we use here. Please stop me if it's hard to understand. So, I want to describe the principle of the aerospace or engine. So, best way to describe is this शेर उर्दू का शेर है तुम दिए बाद मुखालिफ से न घबराए अकाब ये तो चलती है तुझे ऊंचा उड़ाने के लिए. So this is the principle that more you need more opposing air to run this to fly the aircraft engine. और जिंदगी में भी जितनी आपके मुखालफत होगी जितनी आपकी रेजिस्टेंस होगी दैट मेक्स यू स्ट्रोंगर सो आई लाइक this share very much. So let me describe the principles of the aerospace engine. So here I'm showing one of the more schematically one of the more advanced engine, because you may have seen the older aircraft used to have propeller, and the newest like jet fighter, they have jet engine. But the current engines which are used in the aerospace or even at the on the aerospace, they use a combination of that. This is called turbofan. So first stage is this turbofan, which is the larger blades. So they suck the air, and as they suck the air, they move the air engine or the aircraft forward. It's a third law of Newton's motion. Every reaction has a equal and opposite reaction. So they move the air backward, so the aeroplane moves forward. But part of that air is diverted to a compressor, which is several stages. In this case, there are four stages compressor. So it compresses this air, and then go to the combustion section where fuel is burned, and you want to have maximum air because that will you can burn more fuel, and you can burn more fuel, you can generate more thrust. So the fuel I've shown you one chemical reaction that how much kerosene, because the aircraft uses kerosene fuel. So it uses 37 molar volume of oxygen to generate 50 molar volume of combustion product. So not only it compresses the air, but it also increases the volume of that. And then when this hot air, larger volume passes through the turbine section, which is the last section, and it shows three stages of turbine, that pushes the turbine, which moves the shaft, which moves the front of the engine, and the thrust from the hot air, the jet effect, that's what pushes the aircraft. So it pushes the aircraft not only just by pass air, but also from the hot air, which is comes out on the other end. So that is the principle. But doing all this, the temperature in this hot section turbine blade is 1150 degrees C. So the materials really have to be very strong to withstand that temperature. Now, now the same thing I would like to describe a little bit principle of the solid oxide fuel cell power generation. So in the first case, I showed you chemical energy converted into the thrust, mechanical energy. Or if you use the same kind of engine, you can use for power generation like electricity. But I need to talk about that. But here we are directly converting chemical energy from the fuel such as natural gas or hydrogen to electrical energy. And how do you do that? It's very simple. Schematically, I've shown a battery. So you introduce on the anode side. So what is a battery? Battery is like, or the cell is an electrolyte first, and then there is an anode and cathode. So this is true for all batteries: anode, cathode, and electrolyte. Electrolyte allows only the uh, ionic diffusion. So on one side, anode, you introduce hydrogen or natural gas. And on the cathode side, you introduce oxygen or air. And the oxygen from the air diffuses through the electrolyte and meets the hydrogen. And in that reaction, oxidation takes place. And oxidation, by definition, is release of electron. So oxidation is nothing but release of electron. And what is electron? Electron are your electrical energy. So it's basically pumping the electron. So that's how you generate electricity. अच्छा, इसको अब जो मैंने राइट हैंड साइड पे जो दिखाया है वो मोर रियलिस्टिक. सो दिस इज जस्ट स्कीमेटिक. जो हमारा सिस्टम है उसमें द इलेक्ट्रोलाइट इज वेरी थिन. It's right in the middle. Electrolyte is a very thin ceramic material. It's so thin that it is thinner than your hair. Okay, so it's like 100 micron or so. And then you have anode screen printed on that and cathode screen printed. That way you can stack up so many cells. So one single cell, then you make a stack out of it. So single cell, then you make a stack out of it, which have many cells, and then you make a column out of it, and then you make several column out of it. So eventually the total output is 250 kilowatt to you can add batteries, you can add all this equipment to make megawatts of power. And this is the technology we developed from scratch, and nobody is even close to this technology in the world. And General Electric tried this technology, Westinghouse tried this electric, LG, and Siemens, everybody. But we are the most successful, probably 10, 15 years ahead of anybody. So this is one of our system. It was just a pretty picture in a snowstorm. It's very benign. It doesn't emissions are none or very low. So because it burns the natural gas, it does have some carbon, but four hydrogen atom. So you can either capture the carbon or you can burn hydrogen as a fuel, which the product will be water, H2O. So it's very clean system. It's also called clean tech. Okay, now let's see what is needed for these components to withstand these high temperatures. So what first is mechanical strength. You need some of you engineer, if you're an engineering student, you know about yield strength. Is the temperature, sorry, not temperature, the stress at which the material changes its shape permanent plastic deformation. Before permanent plastic deformation and elastic deformation, that means if your stress is less than the yield strength, the material will go back to its original shape if the stress is removed. But after a certain point, even if you remove the stress, that deformation already taken place, and you never want to be at that stress level. And that yield strength of all material decreases as the temperature increases. So then there is an ultimate tensile strength. So that's the strength at which material breaks. Then there is creep resistance. Slow deformation takes place at high temperature, and you don't want that. You want to minimize all these things. Then there's a fatigue resistance, which is cyclic loading can cause the damage or fracture of components. And then you need ductility and toughness and erosion resistant. That means sand and all these things. They shouldn't. The materials should keep their shape. They don't wear out. The physical properties, you need CTE, which is coefficient of thermal expansion. You need to have that matching to other components, so there are no stress is generated. Density is important of this material. Thermal and electrical conductivities are important requirements. Then the higher temperature chemical stability. That means they should not react at high temperature with air or fuel, and they don't wear out. So oxidation resistance in most cases is very important. Materials like iron or steel, they oxidize very fast and they lose their shape, and eventually they just completely form reaction product oxide, and they're no good. So you need hot corrosion resistance. There should be minimum evaporation of the material. But also these materials should be, because you need to form into that material, so formability point of view, the mechanical deformation, they should not be very rigid. They can be deformed, cast. They can make casting or welding of this alloy. So fabrication properties are also required. So these are in general the properties required of high material. Here I'm showing a plot uh, where on the y-axis is the ultimate tensile strength, and you can also say yield strength on the same plot. Y-axis. On x-axis is the temperature. So as you see, materials all have very high strength at room temperature, and then there's up to 400, 500 degrees, their strength has started decreasing. Many material cannot be used, and then there are only fewer material which can be used up to 800, and stainless steel are good. They are used at they can be used up to 800 if there is enough thickness of material. And then finally, after 800 or 870 degrees, the properties even go down, and only few alloys and materials can withstand, and what we call super alloys. So the turbine blades and even in SOFC, which is solid oxide fuel cell, we use super alloys, which are mostly nickel-based alloy, and they also are designed so that their surface is passive. So let's talk about stainless steel. So stainless steel, very common. They use in household items because they are resistant to corrosion, but also good for high temperature corrosion. And what it is, they are iron-based alloys, and they have 11% or more, sometime up to 25% chromium, which is the key element for providing the corrosion resistance. So what happens that if you have enough chromium, it will preferentially oxidize as compared to iron, because thermodynamically, it has high affinity for oxygen, so it comes out and forms the chromium oxide. And we like chromium oxide because it grows very slowly. Iron oxide grows very fast. So it forms a very, very thin layer on the surface. At room temperature, you cannot even see it. The material looks shiny and everything, and there is no chromium. You cannot see chromium oxide. At high temperature, you can see chromium oxide layer, which is opaque. But at low temperature, you don't even see it because it's angstrom thin. Very, very thin. But this is the one which provide the passivation for corrosion resistance. And then in their different series, depending on different alloying element you add for corrosion resistance or for high temperature resistance or for CT. So there are 200 series, 300 series stainless steels, 400 series stainless steels, duplex stainless steel. So then there are the much more specialties. So superalloys, on the other hand, they are nickel based. They can be iron based, but mostly nickel based, cobalt based alloys with lots of chromium, and there are lots of other elements needed for different properties, for high temperature strength, for fatigue resistance, and all that. So they have the ability to withstand these pressures in the turbine engine for 1100 degrees or so. They're very good creep resistant. They over the period like 10,000 hour or 15, 20,000 hour, they do not deform. So that's creep resistance. Then they have also oxidation resistance. So this slide I'm not going to spend much time. It's just for your records. If you want to see some of the commercial superalloys, their chemical compositions is given. One thing I do want to mention that one of the key element is the rare earth added zirconium, hafnium, yttrium. They are added very, very small amount, less than 0.1%, but they increase the life of these components by 10 times or 100 times. So these rare earth small additions, and that was my PhD, to study how much of these elements and what do they do for increasing the life to 100 times by adding only 0.1% or even less sometime. So, so now I want to tell you that what there is a why they are strong, because there is a relationship between structure and property, what we call a structure property relationship, that depends on the arrangement of atoms in a material, lattice structure. So all the chemical and physical properties, how these atoms are arranged. It depends on that, how they can easily deform, they can have a high strength. So that depends on the basic arrangement of atoms. Then there are defects in this when you solidify these elements from the melting to the solidification, they don't perfectly make crystals, but there are interstitial some atom jumps between the atoms. There's interstitial, or there is a space, one missing atom. So these are not perfect crystal, but this is we use to our advantage, because those vacancies and interstitials can be used for semiconductor properties, and also for strength and for diffusional creep properties. They can enhance. So you can use these defects to your advantage in the structure of the element. अच्छा फिर है line defects. So sometimes a whole line of atom is missing during the solidification process. So you use that's called dislocation. In materials term is called dislocation, and that's the key element for deforming the material. जैसे कि आप iron ingot होता है, first you form iron ingot, then you deform it into a bar like saria. So that deformation only can occur if there are line defects in the material. Otherwise, material will be so strong that you cannot deform it. So then there are also grain boundaries. So between the small crystallized together, there are grain boundaries, and they are weak at high temperature and strong at room temperature. So for use of material at room temperature, you want fine grain structure, but for high temperature, you want coarse grain. That means larger, no, less grain boundaries. So then there are strengthening mechanisms, and now I'm getting a little bit too much towards material science now. So there are ways to increase the strength of this material by grain size control, by solid solution strengthening. That means iron and chromium. Well, not only chromium is good for surface property, but it's also make it stronger because it's slightly bigger than iron atom, so it stretches the matrix, so it becomes stronger. Precipitation hardening, you add some material which will make fine precipitate in the structure of the alloy, which will help um, resist grain boundary sliding or deformation at high temperature. Some transformation is strengthening, where phase transformation you can use to strengthen the material, and then just by deformation, material becomes stronger. So there's different strengthening mechanisms. If you cannot get all the properties by single material, then what you do, you apply coating. And one of the common method of coating is thermal spray coatings. That means you have a torch where you have electric arc, and you put the powder of a material. It can melt and propel the molten particles towards your object, and you can apply a coating. So the advantage here, that the temperature between this arc uh, in this plasma spray torch is so high. At the core, the temperature is 50,000 degrees C. So you can melt any material. So you can melt any material. That means you can make a coating of any material on surface, ceramic material. For example, they have very high temperature. You never need 550,000, but in the core the temperature is 50,000. So you need to have water cooling and all those things. And it's a very small area where you have that high temperature. Well, the whole point is that you can melt any material and you can make layered coating. This is the cross section I'm showing on that. Substrate is substrate, which is your component, and you apply coating on the surface, which has the special properties, either oxidation resistance or some other electrical properties. So you can make uh, uh, you can make a composite structure in a way. So this was how much time I have. So Muskan, how much time I have, or should we leave some time for questions?
सर हमारे पास तो टाइम है। अगर सर आप क्वेश्चंस अभी लेना चाहते हैं, सर टोटली डिपेंड्स ऑन यू। अगर आप क्वेश्चंस अभी
नो,
लेना चाहते हैं तो
अगर मुझे आप 5 मिनट और दे दें तो फिर मैं उसके बाद क्वेश्चन ले लेता हूँ।
बिल्कुल बिल्कुल सर।
तो मैं ये बता रहा था कि ये जो टर्बाइन ब्लेड्स होते हैं, एज यू सी द रूट इज वेरी स्ट्रॉन्ग बिकॉज दैट्स वेयर दिस ब्लेड इज हेल्ड. The airfoil is is very high tech. One blade will cost $20,000 because these have intricate cooling paths, and sometimes they grow whole blade out of a single crystal. Because naturally, when you make, for example, water, you freeze it, the small crystallites will form, and naturally, material will form so many grains. But we want to eliminate grain boundaries, so we want a single crystal. So sometimes these are single crystal material. But for surface, you have many different layers of coating for different materials. So this was one of my first project to have coatings for carbon-carbon composite material, because carbon-carbon composite can be very strong even at 2000 degrees C. But in air, at that temperature, they will burn. So they will completely oxidize. So we were looking for making coatings. So I applied some ceramic coating, different layers and all that. Very, very advanced project from US Air Force. So that's what I'm showing here. But then let me just mention that surface stability. So here I'm showing the parabolic rate constant. That means oxidation rate versus the temperature. So as you can see, nickel oxidizes very fast. Chromium oxide next, and the best uh, are aluminum oxide. So if you can make an alloy which can form an aluminum oxide, that is the best because this oxide will grow very slowly. And most of the aerospace engines they use aluminum oxide either by coating, because you cannot put, if you add more than 4% aluminum in the alloy, its high temperature properties or even room temperature properties are very bad. You cannot make an alloy, workable alloy. So most alloys like stainless steels, they use chromium oxide, and many high temperature alloys, super alloys, they use chromium oxide on the surface. But ideally, you want alumina, Al2O3, or silica. It's even more difficult to make. But alumina is a very practical system, and many systems use aluminum oxide on the surface, preferentially oxidized aluminum. You need only 6% to make an aluminum oxide at high temperature. Here I'm showing the weight change. That means how fast they are corroding in thousands of hours. This is the data I took from NASA. So all this material I use in this presentation is publicly available. So I didn't want it to go any proprietary materials from my company or from Praxair. So all this is from open literature. So it is showing that first something these alloys, 310 stainless steel and 800 in alloy, they gain weight, very little weight. That's weight change is per milligrams per centimeter square. And then there's a parabolic oxidation rate, so the rate decreases, and then finally oxide scale cracks, falls off after thousands of hours and start losing the weight. So you want to have slight weight gain, but not start losing weight. So that's the very standard method of testing. Okay. Okay, now I want to just jump into this paradigm of materials development. So in the first paradigm, everything before 1600 century, this was just a experimental. You didn't have science behind it. But after 1600 century up to 1950, the second paradigm of development of material is physical laws, the mechanism, thermodynamics, all this we learn, and we can use those thermodynamic principles just as I said about surface stability and all that. Material development based on the thermodynamics and physics used. Now, now more recently, third paradigm is computational science. So we use density functional, which is quantum mechanics, and what quantum mechanics does, it tells you try to find out the quantum state of the electron, because all the material properties are basically depending on the electronic configuration, or most, if I not say all, most depends on the electronic configuration. So the electron is a quantum particles, and where it is or what speed is going, what is the momentum, and all that thing are important, and that's where Schrodinger equation, if you know, defines the electrons. If you know those things, you can develop new materials much faster. And then there's, of course, what do you call data-driven science, which is what do you call algorithms like neural network or random forest. And I have used all this recently in developing new materials. Some of these I'm just not going to spend. So this is the Schrodinger wave equation. It's just like second law of thermodynamic Newton's, no, second law of motion by Newton. So it tells you the second law of motion of Newton. If you throw a ball, it tells you the speed and the location and everything. But in quantum mechanics, Schrodinger equation does the wave function, and that defines the location and the speed of the quantum particle. So I'm not going to go too much in this detail, but I wanted to introduce that quantum mechanics is used for new material development by using Schrödinger equation, and for this you need supercomputers. Even today, because there's so many calculation involved. For example, a simple system, hydrogen, yes, you can do that. But if you have to do silicon atom, that has 28 electrons, and if you do calculation, you would need 10 to the power 66 seconds, which is the age of the universe is only 10 to the power 17 seconds. So you just cannot solve these problems. So to solve this problem, they use different scientists and engineers, they use different um, simple approximations to come to the solution. But even today, with all those simplifications, we are still needing supercomputers to do any calculation based on this quantum mechanics. So I'm not going to go too much, but Nobel Prize was awarded in somebody solving these equations and simplifying the process. For example, they say it's not important to have actually every single electrons, but the density of electrons can be used as single function. So there are simplified methods used for these calculations of the material properties by using Schrödinger equation and then simplified techniques. So that those are the most current techniques they use in all kinds of material development, biochemistry, surface engineering, catalysts, and so there are thousands of papers published in this area for doing that. So I'm going to end my talk here, and I'm open to questions. I hope you. Basically, I wanted to introduce some concepts. So you probably don't get everything what I presented, like, but in future you will hear that you will see. Oh yeah, so it's easier to understand in future when you're already familiar with some term. For example, density function theory. So if you hear that, oh yeah, this is you have heard that. So that makes it a little easier. Or precipitation hardening of material, or material strengthening, or structure material properties. So I just wanted to give you some concepts. Thank you.
तो थैंक यू सो मच सर फॉर दिस अमेजिंग प्रेजेंटेशन। बहुत इंफॉर्मेटिव टॉक थी। आई गेस
Okay.
डॉक्टर जफर कुछ ऐड
जी
करना चाह रहे
अस्सलाम
हैं।
वालेकुम। जी अस्सलाम वालेकुम एवरीवन।
वालेकुम सलाम सर।
जी आज से 20 साल पहले भी डॉक्टर आदिल अमेरिका में अपने डोमेन में हु थे, एंड माशाल्लाह ही इज़ अ वेरी वेल रिस्पेक्टेड साइंटिस्ट इन द यूनाइटेड स्टेट्स। और आज का जो टॉपिक था, इन्होंने बहुत आसान लैंग्वेज में समझाया कि इवन मुझे भी समझ आ गया कि ये जो भी हम रेयर अर्थ मेटल की बात कर रहे हैं चाइना के साथ, जो यूएस की फाइट चल रही है इस चीज़ में, या जो एनर्जी आगे आ रही है, जो इलेक्ट्रिसिटी आगे बैटरीज बन रही हैं, जो इलेक्ट्रिक कार्स आ रही हैं, तो दिस इज़ द फ्यूचर, दिस इज़ नॉट द पास्ट। तो फ्यूचर में इवन सॉफ्टवेयर इंजीनियर्स को भी बाकी इंजीनियरिंग डोमेन के साथ मिलकर काम करना पड़ेगा। तो इन चीज़ों का इवन हायर लेवल नॉलेज होना भी बहुत इंपॉर्टेंट है। कई दफ़ा आप इंटरव्यू में सिर्फ इसलिए सिलेक्ट हो जाते हैं कि आपको उस टर्मिनोलॉजी का पता होता है। जिस तरह हमें यहाँ पता चल गया कि जी एल्यूमिनियम ऑक्साइड इज़ द बेस्ट अलॉय, फॉर एग्जांपल हमने नाम सुन लिया, हमें रेयर अर्थ मेटल की रीज़निंग पता चल गई कि वो उन पर लड़ाई हो क्यों रही है, उनकी परसेंटेज कितनी होती है। इसी तरह हमें जो है बैटरी है उसका आइडिया हो गया कि वो आजकल कैसे बन रही हैं। तो और हमें काफ़ी सारे इंजीनियरिंग प्रॉब्लम्स का पता चला कि हम किसी भी प्लेन में बैठ के चले तो जाते हैं, लेकिन हम ये नहीं सोचते कि जो इसमें टरबाइन लगी हुई है इंजन में, जो मेटल है वो उसको विथस्टैंड कैसे कर रही है टेम्परेचर को, 1100 डिग्री सेंटीग्रेड को, वो मेल्ट क्यों नहीं कर रही। तो थैंक्स अ लॉट सर, इट्स ऑलवेज अ प्लेजर टू लर्न फ्रॉम यू,
You're
एंड लेट्स
welcome.
गो टू द क्वेश्चंस।
You're doing amazing. iCode is doing amazing job, and that's what I said in the beginning. Nobody is self-made. They need help, and you guys are providing help, which many people before I could grow did not have that opportunity. So this is the amazing thing you are doing. Thank you. I'll stop share.
थैंक यू सो मच सर। सर हमजा आदिल का क्वेश्चन है सर, आप क्वेश्चन कर सकते हैं।
Assalamu alaikum, sir. First of all, thank you for this session. It basically my background is also from chemical engineering as well, and it reminded me of one of the course that we had done in materials metallurgy, in which we also studied about different earth metals and the materials and the technology and the terminology you have used was understandable. My question is that how different companies like you have mentioned Blue Energy are investing on the research about different metals. Like for example, we are investing upon semiconductors. So if we want to keep research on these topics, and if my background or some other metallurgical student wants to learn about or research about this topic, so how they can approach to this field?
So I'm not sure I understood your question very well. You're asking that what research is going on and who is doing the research, or in materials area? Can you just elaborate a little bit? What is your exact question?
Okay. My exact question was that if a student like me, for example, who has done bachelor's in chemical engineering, so
Oh,
if I want to do some research in this topic,
mm,
because in my course I have
mm,
already
mm,
learned about
mm.
metallurgical
Yeah, yeah.
topic.
So
So
if you have
what?
interest, yeah, I think I got it. So you want to see what are the avenues you can pursue research, right? So the first thing, as I understand, you can go to universities. So you want to get a master's. Usually for this kind of research, you need to have a master's or PhD. I'm not saying a bachelor's के बाद you have master's or PhD. So you have to find good university where they have a good material science program like a Stanford here in our area, a very good research program. UC University of California. Usually all schools have material program, and the good ones, of course, are easier. Uh, to find jobs if you're graduated from those universities. So really, your next level would be uh, to get admission in master's or PhD program.
Okay. Thank you.
But all large corporations, they invest in research also. So sometimes, I'm not saying it's never happened, but bachelors, they get involved and they employ and there are lots of in news area or new age, you will see self-learners. So I have seen in myself, even people who do not have college degree, but they are self-learners and they get as much knowledge as a PhD or by learning themselves. So this is another avenue people excel if they are driven. So you don't need degrees. Degrees may help in getting job, but if you are in a position but you start from bachelor's degree, you can still be self-learner and you can be working on the forefronts of the science. It's your own
Okay.
desire, really. It's what you want to achieve. Everything with the
Okay.
new information age is available on your fingertips. So it's easier to do self-learning. But I've seen in my career some people who have done amazing things without degrees. even. But degrees help. So I'm not dissuading you. It's an easier way to get through the degrees first, and then self-learning, of course, is slow. So you want to get master's or PhD if you want to do research in material science.
Okay. Okay. Thank you. Thank you so much.
Thing.
Right. Sir Salim.
अस्सलाम वालेकुम सर। थैंक यू सो मच सर, बहुत अच्छा इम्प्रेसिव वेबिनार रहा है ऑनेस्टली। तो सर मेरा एक क्वेश्चन है कि अगर मैं एज आ मतलब एक रिसर्च करना चाहूँ, इंडिपेंडेंट रिसर्च करना चाहूँ, तो क्या ये मेरी सीवी प्रोफाइल के लिए बेनिफिशियल होगी, या मुझे किसी इंस्टीट्यूट के साथ ही कंडक्ट होके उनसे कनेक्ट होके ही कोई रिसर्च वगैरह करनी चाहिए? ये मेरा बेसिकली क्वेश्चन है।
अगर आपने रिसर्च करनी है, यू आजकल जो है यू कैन डू डेस्क रिसर्च। सो जैसे मैंने आपको बताया डेंसिटी फंक्शन थ्योरी, ओके, or you don't need anything. You can only, but you need to learn crystallography a lot, crystallography, and you can learn your own. So you can do computational materials development. You don't need any, but you need computer resources. As I said, even today, they're using supercomputer, and supercomputer are used mostly for materials research. So, so this you need time on supercomputer, which is expensive. So that's the only thing. But I think it's always help to coordinate with somebody. You just cannot be your own doing. And some of these materials you need to have a experimental substantiation. So you do need laboratories and expensive equipment. So it's not impossible, but more likely you need some cooperation with universities or some companies, just a job employment with a company to do research.
श्योर सर, थैंक यू।
Right. Sir Sayyid Ali Raza.
Assalamu alaikum, sir.
जी
Sir, first of all, it is a very pleasure for all of us to listen you here on iCode Guru platform. And sir, my question is that basically I did my master in physics, and when I research my particularly area was theoretical physics,
hmm.
but I realized that the era of theoretical physics already gone, so we need to move toward computational physics. But right now when I see the shift in technology, particularly ML, machine learning, so then I decided to engage myself in machine learning, particularly the application of physics. But again, I am saying that the side of experimental physics, and basically physics is also touch with your field, metallurgy,
Hmm.
particularly solid state physics and material physics. So,
जी
sir, can you describe me which is the best path to pursue my PhD with the interdisciplinary research, or just focus on the application of machine learning on physics, or I should try to engage machine learning with the experimental side?
I think the fields are wide open. First, you want to get in. Okay. So the biggest thing, like you learn how to apply what is the iCode Guru is doing, how to apply, get some kind of admission and as a scholarship. Those are the very basic steps. Once you get into any university, you will have everything available to you. Once you are in, that's where you can choose, look for the opportunities, whether you want to do experimental research or theoretical physics. There's nothing wrong with theoretical physics. We need people from Pakistan to advance even in the theoretical physics. And and don't worry about reward is really in gaining knowledge. So I think, and everybody can get sustainability. So whatever area fits interests you, you should go ahead. But first thing is to get admission in the university, and then look for whether you talk to different professors, you have a physics background, you have physics masters, which is very solid background. You can go into material science easily. Physics, I have a lot of respect for physics. If you're physics, you can do anything. So, 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 but you need to get some kind of a medium, some kind of a vehicle, and that would be to get a scholarship in any university. You once you have a scholarship, let's say you get a scholarship in physics department, you can always go to materials department and show your interest so that you know a little bit about that area and why you want to work on that. If there are opportunities that once you're physically there, you can do a lot more. So first focus to get into a good university, a scholarship, and then look for what area you want to do research. And having physics degree, you have the foundation. All you need is this specialized techniques, special help which I Code Group provide to get admission.
Thank you, sir. Jazakallah.
Thank you.
All right, ma'am, Amna. After that, ma'am,
Amina?
Khizra, ma'am, आप अपना क्वेश्चन कर लें. I guess ma'am Amna available नहीं है.
Yes, Assalamu alaikum, sir.
जी, वालेकुम
Initially, initially you explained about solar fuel cells. I want to know what efficiency they are creating these days. And you also said that you people are 10 to 15 years ahead of many other companies. So I want to know about the future.
Sure, very good question. So, in terms of efficiency, and that's a very basic question, very good question. So, if you burn natural gas in a gas turbine engine or in a IC engine, you have about 30-35% efficiency, right? But if you burn this, not burn, but chemical oxidation that takes place in solid oxide fuel cell, you get 60%, twice as good as conventional combustion. So electrochemically, you can use this natural gas and you can get efficiency. Our system give you 60 to 65% efficiency. So in conventionally, if you can use 1 cubic foot of natural gas, let's say you generate 1 watt of power, you can make 2 watt of power by 1 single cubic foot of gas. So this is where we have the edge, so at least one edge. Second edge we have is the cleanliness of the exhaust. So we don't have NOx, SOx. Those are nitrous oxides, sulfur oxides. Those are very bad polluters. So we, in our process, very clean process, you don't get any NOx, SOx pollutions in that. The other advantage we have is an on-site power. So for data center, it's the most reliable power. There's no shutdown, there's no maintenance needed because maintenance is always needed, but because we have modular systems, so if there are 1,000 batteries, we may be working maintenance one. So it doesn't matter. We can still keep supplying the same power. So the power reliability is a solid oxide fuel cell gives you reliable power, uh, clean power, reliable power, all time, and then efficiency, of course. So those are the things. And also we can provide timely power. If somebody wants, data center, they are asking for 30 megawatt, 100 megawatt power, and utility company cannot provide that. They will say just forget about 5 years before we can give you that power. So we can do in year to that power. So these are the things which suits this technology for data centers, and my company I work for is doing very well because of that. So I
Can
hope
we
I answered
expect,
your question about
yeah,
efficiency and other things.
yeah, yeah. Sir, I have another question. Can we expect its efficiency to increase in the near future? Like you said, it's 60%. So,
There are some ways, and we are still working on that. Uh, so high temperature, if you can raise the higher temperature, that's even better because diffusion is faster, right? So you can do better, but then you are limited with the costly materials. So these materials which are good for high temperature, they're also very costly. Okay, so
mhm,
then you have to see whether it is worth the increase, the cost benefit analysis you have to do.
mhm.
If you can clean your fuel is better. If you can clean your air is better. So there are marginal uh, things you can do to improve the efficiency.
All
But
right.
the
Thank you so much.
big difference is burning natural gas versus electrochemical. That jump gave you jump from 35% to 60% to 65%. Now, if you want to increase, it will be a couple of percent efficiency increases, but then you have to see the cost is worth doing or not.
Mhm. Thank you so much.
Yes.
Okay, moving towards the next question, Sir Abdul Rahman. मैम आमना अगर अब आप अपना क्वेश्चन पूछ सकें तो अगेन स्टिल शी इज कनेक्टिंग
अस्सलाम वालेकुम सर।
सर जी सर
Abdul Rahman.
सर मेरा क्वेश्चन जो है वो मटेरियल साइंस पैराडाइम से रिलेटेड है कि चौथी और पांचवी पैराडाइम आने के बाद कोई जो तीसरी पैराडाइम है कंप्यूटेशनल मटेरियल साइंस की उसकी सिग्निफिकेंस पे कोई फर्क आया है कि मतलब इनके आने के बाद भी उसका बूम और डिमांड वैसे की वैसे ही है।
फर्क तो है बहुत। क्योंकि आजकल जो रिसर्च हो रही है उसमें मटीरियल मशीन लर्निंग is used a lot in material science research. And I don't know about future, but if we have quantum computing available, that is suited for especially for quantum mechanics because quantum computer is just not a faster computer. I don't know if you guys have heard of the new research in quantum computers. They are not practical yet, they're not commercially available, but they have a promise that they can solve very complex problem very fast, and material science is very suited for that kind of research. So I would say still, if you look at conventional research versus machine learning, is probably marginally, it's probably insignificant because it's still commercial, experimental research or empirical research is still vastly used. Very few people, universities, they are using the computational techniques, and they are making ahead, making progress, and there are thousands of papers and an increasing number of papers are being published. But if you look at today, I think conventional empirical research is way more than machine learning still. But it's the advancing field, and that's how every new paradigm starts.
सर प्रेफरेंस किस पैराडाइम की ज्यादा है लाइक कंप्यूटेशनल की या फिर इंटेलिजेंस साइंस की जो अभी रिसेंटली आई है इसके बारे में थोड़ा सा बता दें
दोबारा
क्योंकि
कहीं
रिजल्ट्स जो हैं वो दोनों के डिफरेंट हैं।
रिजल्ट्स जो हैं वो दे आर नॉट डिफरेंट। आई मीन इफ यू डू गुड रिसर्च देन मशीन लर्निंग से जो आप समटाइम यू लर्न things way better from machine learning. For example, this high entropy alloys, this is another area I'm throwing a new term, high entropy alloys. So before high entropy alloys, few years ago, you make one element and you keep adding single element and you change the properties. High entropy alloys, somebody came up with this idea of making, let's say, five different elements together, mixing 20% each, and nobody thought that you can come back with an equilibrium structure because at high temperature when you melt it all together It may not be, it will be just the phase diagrams. You'll see what phases will exist. So it will all be same. But then they found out that these alloys are unique, and the five different elements when you mix together and they have a high entropy of mixing, that gives the strength to the material, that gives it special properties. And that's why this for this high entropy alloys you need to have machine learning. You cannot do just by because there are so many different variations you can study from 5% in every single percent and five different elements. How many combination are there? You cannot physically make that many melts, or experimental you cannot make those alloys. So you do machine learning. You have to use essential part of machine learning. So machine learning is still used a lot in not still used a lot for the high entropy alloys.
ग्रेट सर। सर चैट में क्वेश्चन है, मैं रीड कर देती हूँ। एज वेरी रेयर पर्सन्स आर वर्किंग ऑन क्वांटम कंप्यूटिंग इन पाकिस्तान, हाउ कैन वी लर्न इट्स बेसिक?
If somebody is using quantum computing in Pakistan, is that the question?
Some persons are working on quantum computing in Pakistan. They are working, and how can we learn its basics?
So it's basics. I would say you learn through literature. It's so much internet is amazing thing available on your fingertips. So you learn first from reading on these papers or these Wikipedia, or you start from Wikipedia. I start from everything new subject from Wikipedia, and then you dig in more into the research paper. You can learn a lot by yourself these days just because of the internet. And then you find out that who is doing. You can and now with AI you can ask question, is anybody doing research in Pakistan on this area? Oh, that will just tell you right away on your cell phone that if anybody is using quantum computing research in Pakistan, that will come just in seconds. So these days, this information age is just all you have to ask.
Absolutely, sir. Sir Hamza Adil.
Hamza Ali,
अस्सलाम वालेकुम सर।
welcome, Salam.
थैंक यू सर, काफ़ी इंफॉर्मेटिव सेशन था। सर मेरा क्वेश्चन ये है कि मैं एक इलेक्ट्रिकल इंजीनियर हूँ और पावर में जो है ना वो मेजर मेरा सब्जेक्ट है पावर। तो मैं अभी जो है ना वो कोशिश कर रहा हूँ कि मतलब यूएसए में किसी भी यूनिवर्सिटी में ना एडमिशन लेने का और प्रोफेसर्स की जो है ना वो रिसर्च पेपर पढ़ रहा हूँ। तो मुझे समझ नहीं आ रही कि थोड़ी बहुत मुझे मतलब एआई की बेसिक जो है ना वो पता है, और मैं चाहता हूँ कि एआई की बेसिक्स एआई को जो है ना वो पावर के साथ यूज़ किया जाए और इस तरह का कोई ना मतलब रिसर्च इस तरह की कोई हो आगे ना पीएचडी में। तो मुझे कोई मतलब प्रोजेक्ट नहीं समझ आ रहा है या रिसर्च एरियाज नहीं समझ आ रहे, या मुझे ये नहीं समझ आ रहा कि बेसिकली क्या प्रॉब्लम्स हैं अभी यूएसए में जिनको जो है ना वो सॉल्व करने के लिए आप रिसर्च कर सकते हैं। तो क्या आप कुछ
Power.
मतलब प्रोजेक्ट्स ऐसे बता सकते हैं, या आप क्योंकि आपको काफ़ी एक्सपीरियंस है और आप इलेक्ट्रिकल इंजीनियर्स के साथ भी होते हैं, तो
हाँ, तो
थैंक यू।
पावर जनरेशन में तो ज़ाहिर है AI is used a lot, and I'm not that much into electrical engineering as much, but again, I would say that uh, rather than choosing the topic right now for research, try to get admission in a university, and then see what grants are available, different professors, talk to them and find match your interest with that interest. But one thing I would like to mention to all the students, the foundational knowledge is very important. So basic knowledge of your subject, master that, then you can do much easier in the research and advanced studies. And so for you, I would say that yes, you want to do power generation, so look at different universities who is doing research in machine learning or advanced techniques, and then apply to that university. Not every university will do power generation research, but for example, Stanford is doing biomaterials research a lot. It's- but you need to research through internet to find the area of interest. And if you want to send me an email, I will provide my email. I would respond better, perhaps, after thinking what your background is, and I can guide you. I'm open to receiving emails and helping uh, people.
Okay, sir. Thank you. I will send you, inshallah.
All right. Sir,
So,
webinar
so
को
Muskan, my email,
yeah,
personal email is adilashri@gmail.com. So anybody wants to reach out to me, I'll try to help better than just in this forum.
श्योर सर। सर मैं स्लैक पर और पार्टिसिपेंट को वैसे भी शेयर कर दूंगी इफ समवन आस्क्स मी।
Hmm.
सर वेबिनार को मोर देन 1 आवर हो चुका है, तो सर डॉक्टर रिजवान हर्स्ट मौजूद हैं टू टेक फर्दर क्यूरीज। अगर सर आप लीव करना चाहते हैं तो आप कर सकते हैं, अदरवाइज सर वी कैन टेक 2 to 3 क्वेश्चंस फर्दर।
I, I'm fine, but I think I'm available. But Dr. Rizwan, you said Dr. Rizwan is available?
यस सर।
Yeah, that's fine. He can take
ओके,
calls.
तो थैंक यू सर। फर्दर
Okay.
क्यूरीज की तरफ जाते हैं। तो
Okay. Thank
सर
you.
मोहम्मद, सर क्या हम क्वेश्चंस ले सकते हैं?
If you're asking me, yes, I'm available.
श्योर सर। So thank you so much, sir. Adil, for your time. Let's move towards next questions. Sir Mohammed Mehtab.
अस्सलाम वालेकुम सर।
जी, वालेकुम सलाम।
सर सबसे पहले तो मैं अप्रिशिएट करूंगा आईकोड गुरु को कि उन्होंने ये प्लेटफॉर्म बनाया, फिर उसके बाद आपको कि आप इस पे आए और हमें आपसे जो है ना बहुत कुछ सुनने को मिला और क्वेश्चन करने का भी मौका मिला।
जी, शुक्रिया। इट्स माय
और
प्लेजर।
सर अब मेरा क्वेश्चन ये था कि असल में मेरा बैकग्राउंड है मैथमेटिक्स से। मैंने रिसेंटली ही अपना मतलब मास्टर्स कंप्लीट किया मैथमेटिक्स में।
हम्म
तो ड्यूरिंग रिसर्च वर्क जो है ना मैंने एक पेपर सबमिट किया था जर्नल ऑफ मैथमेटिक्स एंड कंप्यूटर साइंस में।
हम्म वेरी
तो
नाइस।
उसकी रिवीजन आई थी, तो उसमें उन्होंने ये पूछा हुआ था कि मतलब कि हमने मेंशन किया था असल में पाकिस्तान में ये एक बड़ा प्रॉब्लम है कि मैथमेटिक्स के लिए कि हमें जो पढ़ाया जाता है ना वो थ्रू जो है ना थियोरेटिकल इंस्ट्रक्शंस पढ़ाया जाता है, उसका
हम्म
कोई प्रैक्टिकल एक्सपीरियंस नहीं होता, या
हम्म
हॉस्पिटल्स इंडस्ट्रीज या डिफरेंट इंस्टीट्यूशन के
हम्म
साथ ना कोलैबोरेशन नहीं होती। तो उन्होंने ये पूछा हुआ था कि आपने एप्लीकेशंस, रिव्यूअर ने जो कमेंट्स किए थे कि आपने एप्लीकेशंस तो बताई हुई हैं कि इंडस्ट्रीज में है, मेडिसिन में है, फाइनेंस में है, इंजीनियरिंग में है, तो काइंडली आप इनको जो है ना एक्सप्लेन कर सकते हैं। थ्योरेटिकल आंसर तो दे दिया था हमने उनको और पेपर एक्सेप्ट भी हो गया,
हम्म
लेकिन मैं अब कंफ्यूज इस पे हूँ कि पाकिस्तान में या बाहर फर्दर मैं अब पीएचडी की प्लानिंग कर रहा हूँ करने की, तो मैं
हम्म
चाहता हूँ कि किसी ऐसे इंस्टीट्यूट से की जाए या पाकिस्तान से या बाहर से जहाँ पे जो है ना रियल वर्ल्ड एप्लीकेशंस हों और उन पे काम हो रहा हो, ताकि हमें ये चीज़ें सीखने का भी मौका मिले, एक्सपोजर का भी।
जी हाँ। Yeah, I don't know if I can answer that well. लेकिन वही जो मैं कह रहा हूँ, कई बच्चों ने भी सवाल किए, वही कह रहा हूँ कि आप पहले यहाँ पर किसी यूनिवर्सिटी में एडमिशन लें, then your things ways are open to you lot more. इससे पहले आप unless you are extremely driven, you can do research your own. That's fine, but there are a lot more help when you are physically in a university in US or somewhere. Unless you don't want to come to US, you just want to do there, but then you have to be uh, really good in your own independent material. And I don't know that much in your area, really, mathematics where it is applied. So I cannot help that much. But I think if you want to do PhD, first get the admission, first get there, and then you can choose certain areas of specialization.
सर एरिया जो है ना वो मेरा है मैथमेटिकल इंटीग्रल इनइक्वालिटीज।
Okay.
बेसिकली ये मॉडलिंग में भी यूज होता है और इसकी जो एप्लीकेशंस है ना डिफरेंशियल इक्वेशंस में है।
तो वो आपको कोई और हेल्प कर सकता है? मुझे तो इतना पता नहीं है मैथमेटिक्स की मॉडलिंग का। तो आई कैन नॉट रियली हेल्प इन दैट एरिया।
ओके सर, थैंक यू।
लेकिन आपकी जबरदस्त आपने काम किया है कि आपने पेपर लिखा और पेपर एक्सेप्ट भी हो गया। दिस टेल्स यू दैट यू विल एडवांस, यू विल फाइंड योर वेज।
सर पेपर तो है मेरे पास, एक पेपर नहीं है। मैंने ड्यूरिंग रिसर्च जो है ना काफी पेपर लिखे हैं, जिनमें से 6 मेरे ऑलरेडी पब्लिश हैं और 3 एक्सेप्ट भी हो चुके हैं।
Mashallah, mashallah, very nice, very nice. So this will help you to get admission in some good school. This should. School means university. I call it school. Yeah.
ओके सर, थैंक यू सो मच सर।
Yes. Congratulations,
थैंक यू।
publishing paper.
मैम मानिया।
सर मैं ऑलरेडी फिजिक्स पीएचडी की स्टूडेंट हूँ, सो मेरे कुछ क्वेश्चंस हैं आपके लिए। सबसे पहले ये आपने जिक्र किया मटेरियल साइंसेज में जो कैलकुलेशंस हैं वो काफ़ी लेंदी हैं।
Hmm.
तो इवन तो हमारे पास क्वांटम कंप्यूटर्स मौजूद हैं, तो क्या हम क्वांटम कंप्यूटर्स के थ्रू वो कैलकुलेशंस इसलिए नहीं कर पा रहे कि वो कंप्यूटर्स इतने एफिशिएंट नहीं है, या हमारे पास अभी एल्गोरिथम्स नहीं है उन कैलकुलेशंस को रन करने के लिए?
Quantum computer itself is a research tool, research. So it's not available for public uh, to use quantum computer. Only people, large corporations like Google and Microsoft, they are developing these quantum computers. So they are not available to use right now. Yes, supercomputers are available to supercomputer or conventional computer, and they are available for this kind of research if you get time, and they are expensive time. So only I think it's hard from Pakistan to some university to get to get some time on supercomputer. Maybe there are some universities reaching out and have some international program through Europe or somewhere. Maybe they are doing, I'm not aware of. But quantum computer is itself is a research tool right now. And there's no 100% sure that this will become available. Uh, right now they're making progress. It looks very promising, and it will be
ऑलराइट
perhaps, but we don't know about quantum computing yet.
सर, माय अदर क्वेश्चन इज कि हमारे डिपार्टमेंट में भी काम हो रहा है एमबीई मॉलिक्यूलर बीम एपेक्सी के थ्रू हम प्योर मटेरियल्स डेवलप करते हैं और फिर उनमें
Hmm.
कंट्रोल्ड इफेक्ट्स इंट्रोड्यूस करवाते हैं और उनके बैंड गैप्स वगैरह को स्टडी करते हैं।
Very
सो माय
nice.
माय क्वेश्चन इज to what extent this work has been appreciated in the industry, and other question is how do physicists collaborate with you in the industry?
Luckily, what you just mentioned to me, that I was thinking about to connect you with one lady here. She is doing the very close area research in UC Davis. Her name is Arish. I will talk. I was planning to talk to her to connect, to make connection to you, and she is working on purification of silicon material. So that could be very close connection. Luckily, I think. I'll make sure that you get connected through her. She's finishing up PhD. She's from India. She's Muslim Indian, and I know her personally. Luckily, there is a close interest.
All right, sir. Inshallah, I will reach you through email. So it would be
Hmm.
really nice of you if you can connect me to them
Hmm.
as well. My last question is that अभी हम काफ़ी ज़्यादा सुन रहे हैं एआई के बाद से कि सेमीकंडक्टर्स में जो वर्क है वो काफ़ी ज़्यादा इन्हेंस कर रहा है, तो सेमीकंडक्टर में कौन सा वर्क एग्जैक्टली अप्रिशिएट किया जा रहा है? बिकॉज सेमीकंडक्टर इटसेल्फ एक वास्ट फील्ड है।
Mhm. So yeah, I'm. let me think. The I really am not. I'm not. I don't know as much semiconductor, so I cannot say. But the information in and out, that conductivity of information, that's one research area. I think to make semiconductor better. Uh, but again, I can find somebody
थैंक यू
if
सो
you
मच
have
सर।
interest in that,
थैंक यू
because
सो मच।
there's this is the center of semiconductor research, Silicon Valley, and there are people who are working in that area, and they can guide you. Actually, one guy I know, and Dr. Shai Zafar know also many people in this area. We know Suhail Sayed, who has recently um, sold his company to a large semiconductor company. So these are the very good resources, and they know they are doing research in semiconductors. There are many people available. I can try to connect you with them.
थैंक यू सर।
सर सदुद्दीन।
Hello, sir. Assalamu alaikum.
Well, Islam.
Okay, sir. This is Saduddin and I'm a mechanical engineer from Iranian University, Jamshedpur. Like I graduated in 2022, and since then, like I've switched into the IT and I've been doing work as an AI engineer now. It's been 2 years of experience. So my question is, sir, like I intend to pursue my master's, but there's a confusion in my mind, like should I move into the field of computer vision or NLP, that work I've been doing for a couple of years, or should I go into multidisciplinary fields? Like, yeah, we can find many opportunities present if we look into interdisciplinary fields like mechanical using machine learning algorithm, etc. So, but like if we look into the situation after masters, the job market is not that much rich. Like if we look into computer vision or NLP, so that's my concern. Like, what should I do? If you talk about my passion, like I can do work in any field. That's flexibility present there. But I believe the question is clear.
Mm, I'm sorry, I'm not able to uh, help in that area. But again, as I see it, that best thing for you people in general is to get an admission in a master's or PhD program, and then you look for your passion and interest in that area. I'm not as versatile in every other field. I'm very narrowly focused, as I mentioned, in my area. Excuse me. So I don't know if I can help. मुस्कान एक और क्वेश्चन ले लेते हैं।
श्योर सर। सो हम लास्ट क्वेश्चन ले लेते हैं सर आकिब अली।
Sir, first of all, thank you very much for this wonderful webinar. We learned a lot about material science, data-driven solutions, and the importance of machine learning, and many other valuable concepts. I would like to ask, what interpersonal skills do you think are essential for individual? And additionally, if you were hiring a student, what are the first two qualities or traits you would like for in that person?
So that's a very good question. Um, the thing, if I'm hiring somebody, I'm gonna see that how much how much desire you have to advance. Okay, and also your background, that what you have done, and that those are the two things I will see what you have done and what is your where do you want to see yourself. interpersonal skills are very important in every field. I think the most important interpersonal skill is to give respect to the person. Listen to it. Listen. Don't be biased about. Uh, Always objective. Uh, to to listen to anybody. Just don't make preconceived notions. These are the good things.
Okay, sir, I got it. You mentioned that first of all, you have enthusiasm in any field and your relevant background,
Yeah.
and definitely interpersonal skills.
Yes.
Thank you very much.
Thank you.
Alright. डॉक्टर रिजवान हमारे साथ मौजूद हैं सर इफ यू वांट समथिंग हियर सो सर यू कैन
इवन आप लोग 5 days a week वो तो हाँ वो
So
जी अस्सलाम वालेकुम
I should have let other people answer some of the general questions. I'm sorry. I didn't know that these gurus are available. So I'm gonna sit down right now and let other take the lead on questions.
जी सर आदिल थोड़ा सा मैंने बात करनी थी तो मेरा नाम डॉक्टर रिजवान है मैं हाईकोर्ट गुरु की मैनेजमेंट से मेरा ताल्लुक है
जी
आपसे
हाँ,
मेरी
मैं जानता हूँ
मुलाकात
उसको।
रही है बिल्कुल जी जी बिल्कुल तो थैंक यू वेरी मच फॉर योर टाइम आपने बड़ा एक अच्छा लेक्चर दिया इट वाज वेरी इम्प्रेसिव कि आपने जिस तरह डॉक्टर जफर ने भी कहा जिस तरह आपने चीज़ों को सिंप्लीफाई करके प्रेजेंट किया ना तो हम जैसे लोगों को जिनका मटेरियल साइंसेज में या मेटलर्जी में इतना एक्सपीरियंस नहीं है उनको भी ये चीज़ें समझ आई सो थैंक यू फॉर
Always.
ऑल योर सपोर्ट आपका वी हैव अ रिलेशन और हाईकोर्ट गुरु के लिए आपकी सपोर्ट वी रियली अप्रिशिएट दैट मेरा
Thank
क्वेश्चन तो ये रेयर अर्थ जो मटेरियल है इनसे है कि अभी चूंकि देर इज अ मतलब दुनिया में इस पे काफी फोकस है और जो बड़ी पावर्स हैं वो चाह रही हैं कि वो इन पे एक्सेस करें तो आपको लगता है कि अभी फ्यूचर में जो सप्लाई चेन्स में इसको में किस तरह के इश्यूज आएंगे मतलब क्या हाउ द वर्ल्ड विल गो एज the सुपर पावर्स आर ट्राइंग कि वो उनको
you. Yeah.
एक्सेस मिले रेयर अर्थ मटेरियल्स में तो क्या आपको क्या लगता है कि क्या ये सप्लाई चेन इश्यूज आएंगे या ये चीजें सिंप्लीफाई हो सकेंगी
हाँ, मुझे तो लगता है कि पाकिस्तान has challenges because we do not have industry developed as much to even refine these material or mine these material. So this is a challenging task for Pakistan. But these are real demand. So this rare earths. They are used in solid oxide fuel cell, also electrolyte and everything. So they are definitely there is a demand, but uh, I don't know that side of the business but it seems to me that there are challenges, especially for Pakistan for mining and refining these materials.
चले चले थैंक यू सर थैंक यू एंड होप कि आपसे
Thank you.
दोबारा मुलाकात होगी एंड या
Yeah,
थैंक्स फॉर ऑल
inshallah.
योर हेल्प थैंक्स सपोर्ट थैंक यू सर
Inshallah.
Alright. Thank you so much, Sir Adil, for your
Okay.
talk, sir. It's wonderful
Thank
कि
you.
हमने सर
Anytime.
आपका टाइम दिया
Anytime.
और सर बहुत इंफॉर्मेटिव वेबिनार था हमने काफ़ी कुछ सीखा इस वेबिनार से सो वंस अगेन थैंक यू सो मच फॉर योर प्रीशियस टाइम
You're welcome. It's my pleasure.
थैंक यू
So,
सर
Assalamu alaikum.
वालेकुम सलाम सर राइट सर जफ़र और सर रिजवान हमारे साथ मौजूद हैं अगर किसी को जनरल क्यूरीज हैं तो यू कैन फील फ्री टू रेज योर हैंड अनम्यूट योरसेल्फ मैम आमना खान